Most fans of video games take great pride in their understanding of game mechanics. For the games they play, mechanics become second nature. The purpose and function of each mechanic is easy for the players to test and determine its value. From there, those who look deeper into what is making the mechanics work start to understand and recognize the elements of game design at play. When we start to look very broadly at what makes the principles of game design, we start to see their origins in game theory. Game theory touches on much more than just games and video games. It is used in economics, sociology, mathematics, and within many other fields of study. In each, they are all studying how outcomes involving choice and actions are affected by others with their own choices and actions. Given this broad position of study, we can easily see how game theory can be used in endeavors such as business, social studies, science, and politics. The idea of game theory could be traced back to The Art of War by Sun Tzu. But John von Neumann is largely credited with formalizing game theory into modern times. Neumann was a mathematician who made a number of significant contributions in the fields of mathematics in the 1930s and 40s. He in fact created the field of game theory in academics as a study of math. His most famous contribution in terms of today's video game design was his min-max theorem, in which he showed certain choice patterns people would take if given the same information and the same set of choices. From his work, we get the very core basis of game design. This module will attempt to give some understanding to what can become a very complex and abstract concept dealing with math and statistics. Not to worry, however, because we will explain these concepts as they align with our game design goals and demonstrate examples using familiar video games and other simplified scenarios. In particular, we will cover these topics in our discussion of game theory: the study of strategic decision-making, core components of game theory, and game theory examples in video games. Video games boast a wide variety of mechanics. Most gamers can easily tell if a first-person shooter has good controller reaction and if the button layout is appropriate or not. There's not much game theory happening in these functions. Skill accuracy or button combos are not really in the realm of game theory. Game theory really comes into play when two or more people come to some kind of mutual competition for a goal. It is the interaction of people, decisions, and consequences that drives game theory and why it is so relevant to video game design. We could call this the study of strategic decision-making. We want to understand what the most likely outcomes are, and in particular positive outcomes, when two or more entities are faced with the same or opposing challenges. In effect, we are trying to predict human behavior by using mathematical models. The most famous model example of game theory is called the prisoner's dilemma. The scenario generally goes like this. Two criminal partners have been caught robbing a bank. When they are arrested, they are immediately separated so they cannot communicate with each other. They only know that they both are prisoners. Each is offered the same plea bargain: remain silent and go to trial, or testify against the other and go free. If they both stay silent and go to trial, they will each get 6 months of jail. However, if one is willing to be a witness against the other, that person will have their sentence reduced to 0 jail time, while the other person will get 10 years. If both testify against the other, they will both get 5 years in jail. Both the accused are offered this deal at the same time, with no idea what the other person will do. This scenario creates what is known as a zero-sum game, with each player knowing the entire stakes of each choice. They ask themselves, what is the best course to maximize their own positive outcomes and minimize their own negative outcomes? This, of course, is greatly complicated by the fact that another thinking human is making those same decisions with the same thought process. Each prisoner knows that they will not be able to influence the other's choice with threats or promises, so there is risk involved for any decision they may make. In fact, we have conflict, risk, choices, and consequences all hanging in the balance, just like a good video game. So what do we expect game theory to tell us about the outcome of the prisoner's dilemma? Well, since both the accused are individual agents operating in their own self-interest, the more predictable outcome is for each to betray the other. Of course, we can change the parameters of the dilemma to experiment with different outcome predictions. For example, what if we change the jail times for more slanted results? Would the outcome be as predictable if the jail time reduction for betraying the other was a mere month? What if both of the accused had been in this situation before and remember the negative consequences of a selfish choice? What if they keep playing the game 10 times? Did they learn from their mistakes and make new choices at some point? When we repeat these kinds of experiments, we start to create mathematical models of patterns of behavior. Mathematical models are very important in game theory and video game design. We use them to create complex social and combat mechanics and AI interactions. We use them to create strategy scenarios and real-time strategy games. And we use them to balance player versus player games of all sorts. So can people's thoughts and actions be reduced to a set of probability numbers? Do people function like foreseeable algorithms to the point of accurate predictability? In the case of the prisoner's dilemma, we can only focus on two people, where the winner only wins what the other loses. It does not consider a host of other possibilities and variations in human behavior, complexity, experience, or motivation. The truth is, most things are much more complex than the prisoner's dilemma. What game theory really does is look how people choose solution strategies that have defined value over other solutions. In 1994, mathematician John Nash, who was the subject of the movie A Beautiful Mind, won a Nobel Prize for his work on economics using game theory. Nash developed solution concepts as formal rules of how strategies will be adopted by people in states of competition. The Nash equilibrium states that each player is assumed to understand the optimal strategies of all other players, and that no one will gain by one competitor changing only their strategy. In other words, if all players have adopted a strategy that is the best strategy in relation to other strategies, we have an equilibrium. In video game, this means a balance of strategy among all players, which is essential for a good game design. With the information to determine the best course of action, optimal strategies are formed in the face of like competition. In kindergarten, we learned the golden rule: do unto others as you would have them do unto you. That's a statement that fits game theory very well. Making choices that consider the actions of others is sound strategy.